Now let's do D. Okay, last one here. D says, show how much the radius of any barrel increases if 1 meter is added to the length of a band. State your answer as an exact value, then express your answer to the nearest centimeter. Okay, so if I take any barrel and add 1 meter, how much if I add 1 meter to the length, how much does the radius increase? Does that make sense? If I take any circumference and I add 1 more meter to it, how does that affect my radius? How do you do this?
Could you repeat that?
So I give you some circumference for a band of metal, and I add a meter to that length. How does that affect the radius? By how much does it change?
Well, how much does the band go up by?
The length of the band goes up 1 meter.
Okay, 1 meter?
Yeah. So how does that affect the radius of any barrel?
It'll make it go up by 1 meter.
You think so?
Well, if we look at
That's not what happened with us.
the last one, it went down.
If I went down a meter, did the radius go down a meter? It only went down 16 centimeters. How do you do this one? Oh man. A little bit of fancy math here, and you'll see this happen fairly often in grade 10 math. Here's what we're going to do. We're going to take the formula C equals 2 pi r. Okay. Right now, all this means is some arbitrary unknown circumference is equal to 2 pi times the radius of that object. That's basically what the formula means. We're going to add 1 to the circumference. That will add something. We'll just call that something x to the radius. Follow? And now all we're going to do is we're going to isolate that r. Sorry, not r, x. We're going to isolate x. We're going to isolate x to figure out by how much that something increases. You follow the setup?
This looks just like algebra.
It is algebra. I take C and I add 1. That's also going to increase my radius by some amount, but I don't know how much yet.
Yeah, but how are you going to...
To figure out that how much, we're going to isolate x. Okay? Here's how to do that. We're going to take 2 pi, and we need to get the x out of the brackets, right? So I've got 2 pi multiplying the stuff in the brackets. How do I get that out? The distributive property. So I multiply 2 pi by r and 2 pi by x. So that gives me 2 pi r. Follow? Plus what? 2 pi x. Good so far? Okay. 2 pi r. Does that look familiar? That's the formula for what? Circumference. So instead of writing 2 pi r, I can change that to c. It's the same thing. Does that make sense? If c is equal to 2 pi r, and I have an expression somewhere in my equation that is 2 pi r, I can trade it for c because they're equal to each other. Follow? Okay. Again, I'm trying to isolate x. So what I want to do is I want to bring this c over to the other side, and I'll eventually want to do something with that 2 pi. But right now I want to move that c over. Okay. What's the rule when you change sides? Change signs. So I have c minus c plus 1 equals 2 pi x.
And then it would just be
You got it.
plus 1,
Well, c minus c, what is that?
just C.
If I take anything and I subtract that same amount, I get 0. It turns into 0, right? So that's just 1 now, equals 2 pi x. What's the last thing to solve for x?
divide both sides by.
Just like we did last time. Divide both sides by 2 pi, right? So that gets rid of the 2 pi here. And this tells you the amount by which the excuse me, by which the radius increased. It increases by 1 over 2 pi units.